The star Betelgeuse, a red supergiant and a gigantic celestial body found in the magnificent constellation of Orion, has long enchanted stargazers and cosmologists. This is because of its sheer size and brightness. Assuming that Betelgeuse were set where our Sun is, it would reach the orbit of Jupiter, exhibiting its tremendous size. Despite being located approximately 642 light-years from Earth, its immense size makes it one of the brightest stars visible to the naked eye. Betelgeuse has shown unusual behavior, such as startling dimming and brightening cycles, which many experts believe signal that the star is approaching the end of its life. Renowned physicist Brian Cox recently made a striking statement that Betelgeuse is on the verge of a massive event expected to occur within the next 14 days. This event, a supernova, will mark the end of Betelgeuse's life but will also offer a unique opportunity for scientists to observe one of the most fascinating and powerful phenomena in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been a focal point of cosmic investigations for decades, but its recent erratic brightness variations have sparked theories that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under its own gravity, triggering a massive explosion that releases an enormous amount of energy, radiation, and stellar material into space. Betelgeuse's impending explosion is expected to be a Type II supernova, a specific type of stellar event that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shock wave that destroys the star. The explosion will be so bright that it could be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. Although such an event would typically be catastrophic if it occurred near Earth, Betelgeuse's distance of around 642 light-years means that while the explosion will be visible and dramatic, it poses no threat to life on our planet. Nevertheless, the event promises to reshape our understanding of supernovae and other cosmic phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in seconds than the Sun will emit over its entire lifetime. Betelgeuse's explosion will not only be an awe-inspiring display but also a pivotal moment for science. Experts are eager to witness this stunning event from its earliest stages using a range of ground-based and space telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to gather as much data as possible. When Betelgeuse detonates, it will generate a wide range of radiation, from visible light to gamma rays. One of the most critical aspects of the supernova will be the surge of neutrinos, elusive subatomic particles that rarely interact with matter. Neutrinos from a supernova can reach Earth before the light from the explosion due to their ability to travel through almost anything unhindered. Observatories such as Japan's Super Kamiokande and the Ice Cube Neutrino Observatory in Antarctica are preparing to detect these neutrinos, providing an early advantage in observing Betelgeuse's final moments. The explosion will also yield crucial insights into the formation of heavy elements. When stars explode, they create and disperse elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will give scientists a clearer understanding of this element creation process, vital for comprehending the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is not expected to have harmful effects on Earth, it will interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the release of cosmic rays and charged particles, could result in more intense auroras, extending the regions where the northern and southern lights are visible. While these cosmic rays might impact satellite communications and some technologies on Earth, the disruptions are expected to be minor and short-lived. Perhaps one of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For a month or even longer, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. This spectacle will captivate scientists, amateur astronomers, and the general public alike, sparking renewed interest in astronomy and the universe. Scientists have long speculated about Betelgeuse's demise, but Brian Cox's recent statement adds urgency. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be critical, potentially transforming our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of stellar behavior. Being relatively close to Earth, it offers a unique chance to study how energy from such an event travels through space. By observing the light and radiation from the explosion as it interacts with the interstellar medium, gas, and dust between stars, astronomers will gain a clearer understanding of the universe's scale. The event will also provide a rare opportunity to explore dark matter and its influence on the universe's structure. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, does not emit or absorb light, making it challenging to detect. However, observing how light and matter behave around Betelgeuse after its explosion could offer indirect insights into dark matter's role in shaping the cosmos. Betelgeuse's supernova will also deepen our understanding of the life cycles of stars, particularly how massive stars contribute to the creation of elements essential for life. Supernovae are key cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even living organisms. The data gathered from this event could refine our understanding of nucleosynthesis, the process by which elements are created within stars, and provide critical insights into how these elements are distributed into the interstellar medium. Additionally, the supernova will highlight the dynamic, ever-changing nature of the universe, reminding humanity of the interconnectedness of all cosmic phenomena. As the world awaits this celestial spectacle, the scientific community stands ready to embrace one of the most significant astronomical events of our time. Betelgeuse's supernova will not only expand our understanding of the universe but also inspire humanity to continue exploring the mysteries of the stars. The anticipated explosion of Betelgeuse will serve as a vivid reminder of the universe's dynamic nature, where creation and destruction are intertwined in a cosmic cycle. While the death of this massive star will mark the end of its individual existence, it will also ignite new beginnings, scattering essential elements that could form future stars, planets, and even life itself. The scientific impact of Betelgeuse's supernova will be profound. Researchers will have the chance to study a nearby supernova in real time, something that has not occurred in modern history. This event will likely advance our knowledge in several key areas of astrophysics, including stellar evolution, nuclear physics, and the behavior of matter under extreme conditions. Ground-based and space-based observatories worldwide are already on high alert. Instruments such as the James Webb Space Telescope, JWST, the Hubble Space Telescope, and powerful radio observatories like ALMA will collaborate to capture every detail of the explosion. Their combined observations will cover the electromagnetic spectrum, from radio waves to gamma rays, ensuring no critical data is missed. Additionally, the detection of gravitational waves from Betelgeuse's collapse could provide groundbreaking insights. While gravitational wave detectors like LIGO and Virgo have primarily detected collisions between black holes and neutron stars, a supernova within our galaxy could yield a new type of gravitational wave signal, helping scientists better understand these elusive ripples in spacetime. The educational and cultural significance of Betelgeuse's supernova cannot be overstated. Its dazzling display will inspire countless people around the world, reigniting curiosity about the cosmos. Schools, universities, and science centers will likely use the event as a teaching moment, emphasizing the importance of space exploration and scientific discovery. The event will also underscore the necessity of global scientific collaboration. Astronomers from different nations will pool their expertise and resources, showcasing humanity's shared pursuit of knowledge beyond borders. This collective effort could set a precedent for future scientific endeavors, fostering international cooperation in space research. In the long term, Betelgeuse's supernova might even influence future space missions. By studying how supernova remnants evolve, space agencies could refine their designs for deep space probes and interstellar exploration missions. Insights gained from the explosion could improve spacecraft shielding against cosmic radiation, aiding future missions to Mars and beyond. Ultimately, Betelgeuse's explosive end will serve as both a spectacular cosmic event and a profound scientific milestone. It will deepen humanity's understanding of the universe's life cycles, from star birth to star death, and remind us of our place in the vast, ever-changing cosmos. As we gaze up at the night sky, awaiting the celestial fireworks, we are reminded that even in death, stars like Betelgeuse leave behind a legacy that reshapes the universe and our understanding of it for generations to come. The scientific potential of Betelgeuse's supernova extends far beyond its initial explosion. As its remnants expand into the surrounding interstellar medium, astronomers will closely observe the formation of a supernova remnant, a nebula composed of gas and dust expelled by the dying star. This remnant will provide valuable data about the life cycles of stars and the processes that shape galaxies. Element formation and cosmic recycling. The supernova will create and disperse heavy elements such as carbon, oxygen, iron, and even rarer elements like gold and uranium. These elements are essential for forming planets, moons, and eventually life itself. The blast will enrich the interstellar medium, contributing to the ongoing cycle of star formation. Observing this process will offer scientists unprecedented insight into how these materials are recycled in the universe. Star formation and galactic evolution. Betelgeuse's explosion could trigger star formation in nearby molecular clouds by compressing gas and dust with its shock waves. This process might create new stars and potentially even solar systems. Researchers will monitor these regions over the coming decades to track how star formation progresses after the explosion, shedding light on how galaxies evolve over time. Neutron stars and black hole formation. If Betelgeuse is massive enough, its core collapse could result in the formation of a neutron star, a dense, rapidly spinning remnant left after the supernova. Alternatively, if its mass exceeds a critical limit, it might become a black hole. Detecting such an outcome would be a landmark discovery, as direct observation of a newly formed black hole remains one of astrophysics' most significant challenges. Gravitational waves and multi-messenger astronomy. If gravitational waves are emitted during Betelgeuse's core collapse, observatories like LIGO, Virgo, and CAGRA will detect these signals. This could mark the first time a nearby stellar explosion is observed simultaneously through both electromagnetic radiation and gravitational waves, a milestone in multi-messenger astronomy. The combined data would allow scientists to understand the physics of core collapse supernovae better than ever before. Impact on Earth's future space exploration. The wealth of data collected from Betelgeuse's supernova will directly influence future space missions. Insights into cosmic radiation, stellar evolution, and supernova mechanics could help space agencies design better instruments and safer spacecraft for long-duration missions to the Moon, Mars, and beyond. Public engagement and scientific legacy. On a cultural level, the supernova's visibility will captivate people worldwide. Social media, news outlets, and educational programs will likely turn the event into a global phenomenon. Science museums and observatories may host public viewing events, fostering a renewed interest in astronomy, space science, and exploration among the public. The future of cosmic exploration. The knowledge gained from Betelgeuse's explosion will likely influence astronomy for decades. New theories may emerge, existing models will be refined, and future generations of astronomers will build on the data collected during the event. This supernova could become a reference point for studying stellar life cycles and cosmic events throughout the Milky Way and beyond. Conclusion. Betelgeuse's impending supernova is more than just a celestial spectacle. It's a once-in-a-lifetime scientific opportunity that will advance our understanding of the universe in countless ways. Its explosion will provide answers to fundamental questions about the nature of stars, the origins of elements, and the forces shaping the cosmos. As the scientific community stands ready, humanity eagerly awaits the moment when Betelgeuse's light finally reaches Earth, illuminating the night sky and deepening our connection to the universe.